All right, good morning, everyone. Hope you guys had a nice weekend. Just want to go through first what to expect on tomorrow's test. So tomorrow's test will just be going over Riemann sums and differential equations. Okay. And it'll be a 50-point pre-test. It'll be Riemann sums, and it may have particle motion built into it. Depends on the problem. So you want to make sure that you review particle motion FRQs. Those are from Monday and Tuesday of last week. So look through those worksheets, 412 and 413. It could look like this, where you have a table of values involving velocity, and you take the integral of velocity to get displacement, or derivative to get the slope to get the acceleration. The integral of velocity is total distance, right? And all this is on the formula sheet that will be provided for you. And it's the same formula sheet that you guys got attached to the back of worksheet number 1 from Friday. Okay, so expect we'll practice Riemann sums today. And also the second is going to be a differential equation, where you may see slope field as well, but slope field will just be an easy one where, well, the differential equation, you got to go through separating variables and all that, but just want to, slope field, I did not include it on the worksheets, but it is on the homework worksheets. So something like this, where I give you a bunch of indicated points, and then you take those order pair, dump it into the derivative, you get a number in return, and you interpret that number to be a slope segment, either positive, then you do positive slope. If there's a negative number, you create a negative slope segment. If it's 0, you create a horizontal line. If it's undefined, then you leave it empty, right? Leave it blank. Okay. I'll have a help session this afternoon going over homework number 7 worksheet. Last Friday, I had a help session going over homework number 6. And tomorrow morning, I'll go over morning review worksheet number 3. Yeah, but I encourage you guys to look through these review worksheets that we did all last week. You can ignore antiderivative word problems. This will not be on the test. Okay. But it's still an important topic. That's why I kind of I spent a day on it, since most likely will show up on the AP exam. Differential equation from Thursday, just more differential equations for you to practice with. And then Wednesday is when you guys will turn in your assignment 1 through 5 through teams. 1 through 5 is just the assignment from the Friday before break to last Thursday. Friday and yesterday and tomorrow's work, that's all due the next batch there, which is 428. Okay, any questions? Okay. Yeah, and the formula sheets will be attached to the back of your test. Okay, so let's look at day 2 notes. All right, so it says watermelons are beginning to come into season, and the warehouse is receiving the watermelons over time. The strictly increasing and twice differentiable function, smooth curve, models the total number of watermelons in the warehouse with t greater than or equal to 0 weeks. It is thought that W will satisfy the differential equation dW dt, where W is measured in number of watermelons, T is measured in weeks. At T equals 2, There are 10 watermelons in the warehouse. Part A says write an equation of the tangent line to the graph at t equals 2 weeks. Use your tangent line to approximate the number of watermelons in the warehouse at t equals 3 weeks. So first things first, we're going to create our tangent line equation. So we need to order pair, and then we need to find slope. Okay, so order pair. No, we're used to seeing order pairs in terms of x and y, but we need to adapt this the variables to be now in terms of t and w. T for my, think of t as your independent variable and w as your dependent variable. So we know at 2 weeks, there are 10 watermelons. So order pair 210. We also need slope. Slope comes from the derivative formula. So I'm just going to insert 2 in for t and 10 in for w. Okay, there's my formula there. Okay, 4 times 1 is 4. I have my order pair, I have my slope. Now I can do point slope form. Point slope form, we're maybe more familiar in terms of x and y. So I'm just going to write this out first, and then we can adapt using the variables in our problem. So instead of y, I'll use w. Instead of x, I'll use t. Replace T1, W1, and M. We're going to solve, this is our tangent equation, but we're going to solve for W to get it ready for the next part, because it says use the tangent line to approximate the number of watermelon at t equals 3. So we're going to do some linear approximation after we get that W by itself. So I want to use the tangent line to approximate how many watermelons when t equals 3 weeks. So I'm just going to plug 3 in for t. Okay, 4 times 1 is 4. 4 plus 10 is 14. So 14 watermelons is the approximation in week 3. Okay, any questions? Okay, let's look at part B. Find d2w over dt2. That's just a notation for second derivative. Okay, so to find second derivative, we're going to first start with first derivative, right? We're going to start with this dw dt and see if we can make our way to the second derivative. Okay, so if we look at how this dw dt is organized here, we have 2t times w minus 9. If I want to find the derivative, what's involved here? Okay, what else? Product. You see how these are two separate variables there? Yeah, we got to go through product rule here. Oh, okay, got it. Okay, so that's what you meant. Okay, product rule. Okay, and also there's a little bit of related rates going on here because you see how this is over dt. That means time is the independent variable. So each time we find a derivative, a t is going to appear, but t is the independent variable here. So dt over dt is just not going to make an impact, but this w is going to be impacted by time. Okay, but I'll set this up. F prime g plus f g prime. Two t becomes 2. G stays. Back to f. And then g prime, w minus 9 becomes, well, w becomes dw dt, and 9 goes to 0. Right? Okay, so let's take a moment and make sure everything makes sense. Any questions here? Okay, now that we have the second derivative, it says use the second derivative to determine whether our approximation is over or underestimate. So we're going to have to find, we have to be able to attach a numeric value to the second derivative. So we're going to have to, it says use the estimation that we found from part A. So I'm going to use this order pair here, 314. I'm going to insert this into the second derivative and try to get a number, and then use that number to help me decide whether I can make a conclusion about whether this linear approximation is over or underestimate. So I'm going to insert the order pair here. So 314. And the order pair is just going to, we're going to have to find a numeric value for w, replace t, but we also need to find the replacement for dw dt, and we'll get to that when we get there. So I'll take care of this first part here, and then we'll talk about how to handle that dw dt. Okay, 14 in for w, 3 in for t. All right, so we're down to dw dt. We need to have a number for this. Right now, we don't really see a variable that we can enter in, but we know dw dt came from this starting point, And if dw dt is 2t times w minus 9, now all of a sudden we have something that we can insert and find a numeric value for. So we're just kind of going back and searching for something that we can actually plug in. So dw dt is just 2t times w minus 9. Just going to take that and insert that here. T is 3, w is 14. So 6 times 5 is 30, so 30 is going to go in this slot here. Okay, so 14 minus 9 is 5, 2 times 5 is 10, 6 times 30 is 180, 180 plus 10 is 190. Okay, so the significance of this number, all we care about is whether it's positive or negative, because if we're dealing with a positive second derivative, we know that it's going to translate to concave what? Concave up, yeah. So if the graph is concave up, that is going to give us certain information for us to conclude whether our approximation is going to be under or over approximate. So I'm going to say since since WT is concave up, and you don't have to draw this, but I just want to be able to convince you that if my graph is concave up, it doesn't matter where my tangent line is, it's always going to sit safely below the curve, right? It's going to under approximate. Okay, any questions here? Okay, part D, we're going to solve the differential equation. Sorry, part F. So we're going to set things up with numerator over denominator equal to numerator over denominator, cross multiply, separate the variables. Again, I know we're used to seeing maybe y's on the left, x's on the right, but in this case, we're going to be grouping w's on the left and t's on the right. Okay, here's my cross product here. I haven't achieved full separation, but I did make progress in terms of getting the dw and dt in their right slots. And now we just have to figure out how do we get full separation. There's one thing that's out of place, and it's that w minus 9, right? So we're going to shift that w minus 9 over to the left side. We'll divide the w minus 9 over. The 2 is in the right place. The t is in the right place. It's going to be sitting next to that dt. Just that w minus 9 is going to move over. Okay, so it's important that you get to this point because we need to be able to separate the variables correctly. Otherwise, it's going to be hard to earn points after this, right? So let's make sure that we're comfortable cross multiplying and we're comfortable moving things around and getting all the variables in the right spots. Okay, we're ready to explore integral rules. Right side is power rule, but the left side we'll go through a little bit of U-substitution to see if we can get it ready for what we suspect to maybe be a natural log rule. Okay, setting up both sides here. Left side is natural log, right side is power rule. Okay, so 1 over u du is just natural log acid value of u. 2t dt, we go through power rule. Do a little bit of cleanup. I have the antiderivative. I got a plus c to show up. I'll bring the w back into my expression, and I'll clean this side up as well. Okay, any questions so far? Okay, so once you get that plus c to show up, you always have two decisions or two paths available. You can either solve for c now, or you can solve for the variable first, get to the general equation, and then solve for c. You always have two options, and sometimes one is easier than the other or faster than the other, but they're both going to get you to the right answer. On the key, I worked it out solving for w first. So here I'm going to solve for c first, and you can kind of decide which method. I think the reason why I want to solve for c first here is I see my order pair being 210, and it's not a 0 involved, and I tend to think that maybe it's a little messier without that 0 later on. So I'm going to solve for c while it's still maybe a little cleaner. But I think ultimately it's roughly the same, just I want you guys to be able to see different variations of it. Okay, so I'm going to solve for c here. Okay, so 2n for t, 10n for w. Ten minus 9 is 1, natural log of 1. Natural log of 1 is 0. Solve for c. 0 equals 4 plus c, so c equals -4. So I elected to solve for c first, so I'm going to enter that -4 back into my general equation, and then I can shift my focus to try to get that w by itself. Okay, I have that c value resolved. Now I want to get that w by itself. I see natural log in the problem. I want to undo that natural log, so I'll involve the inverse, which is base e E and natural log are going to undo and cancel each other out. I'm left with absolute value of W minus 9. Okay, so I want to solve for W. I want to drop the absolute value, but if I drop the absolute value, I need to balance it out on the other side with a plus or minus. Add the 9 over to the right side. Now, we have to understand that we're staring at two separate solutions, two separate equations, but we only want one of them. And the way we decide which one to choose is we go to the order pair, because the order pair is going to tell us which one is going to be the one that we keep. And you look at the y value. The y value, whatever the sign of the y value is the sign of your equation. So I got a positive 10. That means I'm going to choose the positive value. Normally we see this with square roots, and the reason why it shows up here is because I elected to solve for c first rather than waiting to the end. Okay. So we'll choose the positive answer. Okay, questions? All right, for part G, it says for the solution that we found, evaluate W of 0. So we're just going to enter 0 in, and because this is going to be the equation that tells us how many watermelons there are at a given week. E to the negative 4 is just ends up being a really small number. So if you enter in the calculator, it's like 0.018. So it's going to round to be about 9, right? It's not going to make an impact enough for me to make my approximation. So we can say at time t equals 0, we expect there to be 9 watermelons. Okay, questions? Okay, back page. Okay, the function f has derivative f prime, where f prime is increasing and twice differentiable. Twice differentiable, so smooth curve. Selected values of f prime are given. It's known that f of 0 equals 3. For f prime of x, the conditions for mean value theorem are met. The conclusion of mean value theorem over the interval from 0 to 3 is that f prime is satisfied at c equals 1. So mean value theorem let's look at the original formula and see if we need to make any adjustments. So f prime of c, so again, mean value theorem just says whatever slope exists between the endpoints, that slope is guaranteed to show up along the curve somewhere. Right. So we know that we're trying to, but we're not trying to guarantee a slope on the f of x graph. Looks like we're trying to guarantee a slope on the f prime graph. So I'm just going to make some adjustments here. Since I'm looking for f double prime of c, I'm going to have to drop these initial values to be in terms of f prime, right? So everything is going to have to drop by 1 degree here. So I'm going to adjust my formula so that it fits our problem. We know our C value is 1. We know our A and B values they're always given, 0 and 3. So I'm just going to fill everything in and see how the table can help me out. Okay, so f prime of 3 is 4, f prime of 0 is -1. So I get 5/3. Okay. So that means on the f prime graph, there is a slope of 5/3, and that 5/3 is going to have to show up somewhere along that path. Okay, questions with A? Part B, use the right Riemann sum with 3 subintervals. Approximate the integral from 0 to 5 of f prime. Squiggly line to indicate we're dealing with approximation. Okay, so I'm going to mark my intervals there. Subtract the widths, 2 minus 0, 3 minus 2, 5 minus 3. And then do width times height. I want to choose the right y value of each subinterval to represent the height of the respective rectangles. Next up, is this an over or under approximation? Okay, so we have some clues here. First is the fact that our function is always increasing, our f prime is always increasing. And the second hint is that we're dealing with the right Riemann sum. So there's no need to memorize any of this. We're just going to draw it out and see if we can convince ourselves whether these rectangles are going to sit below or above the curve. And then from there, we can decide whether this is an under or over approximation. So I'm just going to draw an example graph here. I'm not going to be really specific here. I'm just going to create an ever-increasing graph, and I'm just going to draw rectangles where I'm forcing the right endpoint to attach to the curve. And you see all these rectangles that we draw are all going to sit nicely above the curve. So we know this is going to be an over approximation. Okay. Part C, this is kind of like something that you've seen on the previous FRQ, where we go through U-Substitution, we go through first theorem, we use our table of values to get this down to a number. So let's target that 2x minus 1 first. U-Substitution. We'll go ahead and replace our x's with u and du. We'll leave the bounds out of it for now. I'm going to push that 2 out in front as 1/2. So we don't do anything like power rule, right? We know that f double prime of u is just going to rise up to f prime. That's just first theorem. That's just application of first theorem. So take care of the antiderivative. So we have our antiderivative, and now we have to figure out how do we work in the bounds. There's two methods. You can either convert the bounds in terms of u, which I kept stressing because that's maybe not the method that you would prefer, but it's the method that it shows up quite a bit on multiple choice, where you're forced to have to go through that method because that's the answer choices are all in terms of u. But if it's free response, maybe it's faster just to bring everything back in terms of x, and then we can just have a match between our variables. We don't want to do this. We don't want to plug 2 and 3 in for the u, because then we're having a mismatch of variables. Okay. So I'll bring that u back in terms of x, 2x minus 1. This is already my antiderivative. Whoops, my 1/2 is also there. And then I'm now ready to insert my bounds. Okay, upper bound gets evaluated first. 3 in for x, that's 2 times 3, 6 minus 1 is 5. Next up, lower bound. 2 in for x. 4 minus 1 is 3. We look at the top of the page, table of values. We have specific values that we can insert there. F prime of 5 is 7. F prime of 3 is 4. So 7 halves minus 4 halves is equal to 3 halves. That's our answer. Okay, questions with C? All right, let's do, this is another differential equation here. So go through our process, cross multiply. Okay. After I cross multiply, I have my dy, my dx set up where they're in the right places. The only thing that's out of place is that 3 minus 2y, so I need to divide that over. Okay. Variables separated. Explore integral rules. Left side, I got to go through U-Substitution. Now I'm going to be expecting some coefficients I got to keep track of here. Push the negative 1/2 out. Natural log on this side. I know f double prime is going to rise up to f prime. Replace the u back in terms of the original variable. I think on the key, I think I solve for y first. I think I'm going to solve for c here. Maybe that's a little bit cleaner. So I don't have to deal with as much. Yeah, so I'm going to solve for c first, see if that will be a little less messy. So there's my initial condition, 0, 1. Okay, 0 in for x, 1 in for y. this is 3 minus 2, which is 1. Natural log of 1 is 0, so this whole thing is going to be wiped out to be 0. F prime of 0, we have to refer back to our table here. So F prime of 0 is going to be negative 1. Okay, so I have the C resolved. Now I'm just trying to get that Y by itself. All right, so a couple of things here. I'm going to multiply everything through by -2 to get that -1/2 to go over. That way I can get this left side to clean up nicely. So -2 times -1/2 would just be just 1. Involve E to undo that natural log. Drop the absolute value. Plus or minus is going to show up. Solve for Y, so I'm going to have to subtract the 3, divide by -2. Let's see, 0. Okay. I'm going to choose the positive one here because of that plus or minus there. Okay, it says use the expression to find h of 2. We're just going to stop here. I'm not going to go ask you anything beyond the solving differential equations, so just get to that equation. That's good enough. All right, so go back, make sure that you review through the worksheets that we did last week. It's just going to be centered around these two topics. Particle motion may be part of your table, so look through that. Help session this afternoon and tomorrow morning. Okay. Again, anti-derivative word problems is not going to be on the exam, so on this test. So just focus on the worksheets that we've been going over since last week, and then these review worksheets and homework from this week. Okay, thanks everyone. Hope you guys have a great day. Study for your test. I'll see you this afternoon or tomorrow.
Mr. Yang,
Yes.
do you use the positive equation because of the sign of the y value, or am I thinking of something else?
Yeah. I use the positive because of the sign of the y value.
Okay, thank you.
Okay, thank you.